Welcome back to Beyond the Comfort Zone Talking Shit with KING-KAMBUF.
Today we're not. We're not really looking at theory or, some abstract forecast.
No, not at all.
We are diving into a piece of source material that is immediate, it's demanding, it's utterly actionable.
Command brief.
A command brief, exactly. This is a blueprint for physical economic transformation, and it's written with the urgency of a mission directive.
I'm glad you said that,
Yeah.
because our source material is titled The KAMBUF National Building Design Command Brief and National Projects. And when we say command brief, you really have to feel that. This isn't some relaxed, request for proposals.
No.
This is a high-stakes, rapid delivery document. It's setting the stage for nation-building infrastructure.
And the theme of this highly charged sprint, it's right there in the title, it's Agro-Industrial Food Systems and Circular Materials Infrastructure for KAMBUF City-States and Diaspora Gateways.
That's a mouthful.
It is, but it's incredibly strategic.
Yeah.
It combines two fields that are usually, kept separate, food production and waste management, and puts them under one single architectural umbrella.
Okay, so let's unpack that central mission. When they say that, what they're really talking about is a directive to achieve food sovereignty and materials sovereignty.
Yes.
It's taking these big abstract concepts of national resilience and turning them into physical, designable assets. We are looking at building the actual systems, the processing plants, the logistics corridors.
Recycling centers?
All of it. The things that fundamentally break a nation's reliance on external markets for, the basics, for necessities.
That concept of sovereignty, that's the engine for the entire brief. I mean, food sovereignty is pretty clear. It's the ability to feed yourself, controlling that whole supply chain from seed to table.
Right.
But material sovereignty, that's the ability to control essential industrial inputs, things like construction materials, packaging, even energy from your own local resources.
And often those resources are just previously discarded waste streams.
That's the circular part. Exactly.
And crucially, this brief has a governing philosophy, a kind of North Star that defines what success even looks like. It's called the Rotating Master Challenge Focus. And for this set of 10 schemes we're looking at today, the focus is, without a doubt, environmental performance.
Absolutely. And you have to understand, this goes so far beyond your standard, green building compliance.
This isn't just about putting solar panels on the roof.
Not at all. The brief demand systems that are optimized for life cycle material flows, for circular economy principles, for regenerative agro systems, and this is critical for low carbon production.
And the real challenge, it seems, is that these environmental metrics, they have to be baked into every single phase.
Every phase.
Yeah.
Design, procurement, delivery. They are not metrics you calculate after the building is finished to see how you did.
No, they're the design drivers.
They are the design drivers before the sums line is even drawn on the page.
So if a designer is specifying, say, concrete, they aren't just thinking about its strength or its cost.
No, they have to be thinking about its embodied carbon, what's at the end of life cycle. Can it be reused? It forces this complete integration of environmental accounting directly into the creative process itself.
It basically turns architects and engineers into forensic systems analysts.
That's a great way to put it. They have to preemptively optimize everything, the environmental performance, the economic performance. It's an exercise in embedding circularity and autonomy right into the physical DNA of a project.
Okay, so we've got 10 of these visionary design schemes, or as the brief calls them, portfolio drills. They're laid out here, spanning the African continent and even reaching out into the diaspora. So today, we're going to reveal how this foundational infrastructure is being designed to transform waste into value and a dependency into real, robust autonomy.
Let's get into it.
To really get the significance of these 10 projects, you have to internalize what they call the KING-KAMBUF closing directive. It's like the moral and economic foundation for the whole mission.
And it is so simple and so powerful. Food is power. Materials are sovereignty.
Right. And that one directive, it just elevates everything. Infrastructure design suddenly becomes a geopolitical act.
It does. I mean, historically, waste management and logistics, they were seen as, municipal maintenance, janitorial work on a city scale.
Just keeping the streets clean.
Exactly. Here, they're being leveraged, maybe even weaponized, for national autonomy. By designing systems that control your own food supply and ensure a reliable local source for construction materials, you basically immunize your economy against global trade disruption.
Or currency shocks.
Or currency shocks. You're decoupling from that volatility.
It fundamentally redefines what a local resource even is. Waste that stops being this liability you have to pay to get rid of.
Right.
And instead, it becomes a localized, controlled industrial feedstock. That shift, that one mental shift, changes the entire economic model of a city from, linear consumption to a closed-loop resilience.
And to achieve those closed loops, you need very specialized foundational infrastructure. The brief is really clear about the components that have to be designed across these schemes.
What are we talking about?
We're talking about highly efficient agro-industrial hubs, complete with specialized value chain logistics. We're talking sophisticated circular materials recovery centers, which need advanced sorting and cleaning tech.
And not just sorting, right?
No, just sorting. Then there are modular production plants for creating new food products or materials, like, say, recycled plastic pellets. And, of course, dedicated biomass or organic waste-to-energy systems.
I think that distinction between a recycling center and a circular materials recovery center is so important.
Too critical.
Because the latter implies you're not just collecting cans and bottles. It implies you are processing them back into high-quality, traceable industrial inputs.
That's the step that completes the loop locally. It prevents you from just exporting your valuable waste for someone else to process and sell back to you. It's about capturing that value.
Now, before we jump into the specific locations of these projects, we have to talk about how this autonomy is measured. Because the brief is, it's relentless in its quantified goals. The ESG impact section.
Yes, these are the accountability metrics. This is where the rubber meets the road. The success of a design isn't judged by how it looks.
Not by aesthetics.
No. It's judged by hard numbers. The percentage of waste diverted from landfill, the co-euro reduction, the number of local jobs created, and, importantly, the amount of food value retained locally.
Okay, let's focus on that last one for a second. Food value retained locally. That's more than just growing local crops, right?
Oh, much more. It means the facility has to ensure that all the activities, the cleaning, the processing, the branding, the packaging, the distribution, all of that happens within the project's immediate economic sphere.
So if a farmer grows tomatoes?
The goal isn't to export raw tomatoes. The goal is to process them into tomato paste, package them in local circular containers, and sell them locally. You capture 100% of that value chain.
It's the difference between being just a supplier of raw inputs versus being a controller of the entire value chain.
Exactly. And when you link these socioeconomic goals, like job creation, directly to the environmental metrics like co-euros reduction, you ensure the project is inherently sustainable on multiple levels. It has to be a holistic success.
Okay, so with that framework in place, sovereignty through design, measured by performance, we can finally jump into these 10 portfolio drills.
And you have to see them as interconnected. They're designed to form a continent-wide network of resilience.
Right. And we start in West Africa, where, urbanization and material management are just these immense primary pressures.
The first one is Scheme 1, targeting Lagos, Nigeria, the integrated campus. Lagos is just a massive, incredibly dense urban environment. Managing materials there is a monumental task.
So the location is on the city periphery, right?
Yeah.
Where the urban sprawl kind of bleeds into the productive hinterland?
Precisely. And the core challenge is one of integration. You have to integrate this high-efficiency food processing. Think of the volume of local crops you need for a megacity like Lagos.
Unbelievable.
With material recovery systems for the literal mountains of urban waste. Plastics, packaging, organic materials, all of it.
So this campus has to be a dual engine. It's feeding the city and cleaning up the city, all while trying to generate export revenue.
And that dual mandate is reflected directly in the required structural detail they ask for. They mandate a modular steel frame built from reclaimed materials.
Okay, that's not just a nod to sustainability.
No, it's an operational demand. Using reclaimed steel, yes, it significantly reduces the embodied carbon of the structure.
Yeah.
But more importantly, it establishes a high-value internal market for the very materials being recovered and processed right there on campus.
You create your own supply chain. I have to pause on the word modular, though. In a high-speed command brief like this, why is modularity so essential, especially with steel?
Modularity is all about speed of deployment and flexibility. Lagos is growing and changing at an incredible rate. A modular steel frame lets you build fast, using standardized connection details. It ensures you can scale up or adapt to new material streams very, very quickly.
So it's an architecture that's designed for agility and growth, not for rigid permanence.
Exactly. And the brief even specifies that the roof spans have to be optimized for solar collection and bioventilation, which further integrates that environmental performance right into the passive systems of the building itself.
The public comms angle for this one sums it all up. Food plus materials sovereignty. It's simple, direct, powerful.
So from there, we move along the coast to Scheme 3, which targets Abidjan, Côte d'Ivoire. Here the focus is on blue-green value.
Okay, blue-green. Abidjan is a major coastal and lagoon city, which introduces totally different climate risks and, I imagine, different waste streams.
It does. So the challenge here is more complex. How do you combine the blue food systems, we're talking aquaculture, coastal fishing, with the green systems, the circular materials, in a zone that is highly susceptible to sea level rise and pollution?
So they're literally designing resilience against water-based threats using material cycles.
That's the idea. And the required material innovation they specify is the biomass to bioplastic processing cell. This is where the systems really start talking to each other.
How so?
Well, aquaculture generates a lot of organic waste. Instead of letting that pollute the lagoon, this waste, combined with other local agrarian biomass, gets treated and converted into feedstock for bioplastics.
And those bioplastics can then be used for what? Local packaging?
Local packaging, maybe even construction components.
Okay.
It fundamentally internalizes the waste loop of that entire coastal economy.
Wow. That is a perfect example of design creating value where before there was only pollution, you're turning a liability, all that coastal organic waste, into a valuable industrial input. You solve two problems at once.
Right. And then finally, in this West African cluster, we have Scheme 9, focusing on Timaport in Ghana. This one is called Digital Meets Circular.
Okay, Timaport is a huge, crucial node in global trade.
It is. And this project is about combining advanced digital trade services with physical circular manufacturing and food processing, with a heavy emphasis on export.
And the brief specifically demands integration with the Africa Continental Free Trade Agreement, the ACFTA.
Correct.
So for you listening, FCFTA is the framework aimed at creating a single continental market. This facility can't just process materials, it has to be compliant and digitally plugged into these massive continental trade flows.
And given that industrial use, the physical demand on the building is high. The deliverables require a composite floor structural system designed for heavy live loads. This is necessary to support the SME pods and factory space where the material processing and food packaging actually happen.
So we're not talking about a simple warehouse here. This is a high-stress, multifunctional industrial incubator.
Precisely. And the metrics reflect that trade focus. They're measuring success in TEU growth, that's the standard measure of container traffic, and the number of local SME jobs created.
It makes the port facility a place of production and value retention, not just a place where goods are, passively imported and exported with minimal local benefit.
A very different model.
So now let's shift over to East Africa. Scheme 2 addresses the Nairobi Rift Valley corridor in Kenya. And the challenge here feels like pure logistics and social equity. The title is Shrinking Food Miles.
Yes. Nairobi is a massive consumer. The Rift Valley is a massive producer. The goal is to optimize that supply chain.
To dramatically reduce the distance food travels from the farm to the plate.
Right.
And to integrate packaging reuse, and critically, to make sure the infrastructure actually benefits the smallholder farmers.
The smallholders often get squeezed out by the large supply chains.
Exactly.
And the quantifiable goal here ties the design directly to that social impact. They measure success by the reduction in truck kilometers traveled and the increase in the smallholder count benefiting from the system. If the infrastructure doesn't demonstrably benefit smallholders, it fails its mandate.
So what's the physical asset that actually achieves this? What are they designing?
It comes down to two things: the community packaging hub and the reusable packaging module design.
Okay, what does that mean?
The design brief demands a standardized, durable, reusable packaging system. Think stackable crates or bins, something that reduces the need for disposable packaging and lowers material costs for small farmers.
And the hub is the central point for that system.
The hub is where these modules are brought back, cleaned, standardized, and redistributed. It creates a clean-loop logistics system that maximizes efficiency for everyone.
It's like a logistical puzzle being solved through material design.
It is. And then right next door, we look at Scheme 6, the Ethiopia-Djibouti corridor. The focus there is the waste-to-energy nexus.
Now, this railway corridor is absolutely essential for landlocked Ethiopia to get to the coast.
It's a critical artery. And this project links the large-scale agribusiness output that moves along that corridor to a circular compost system, and then generates energy from digesters located right near the transport line.
This is a direct play for energy sovereignty using local resources, and it's happening right near a major geopolitical choke point. The technical detail they require is the design of the anaerobic digester structural cell.
Precisely. An anaerobic digester takes organic waste agricultural byproducts, municipal sewage, whatever, and breaks it down in an oxygen-free environment.
And that produces biogas?
It produces biogas, mostly methane, which is then converted into electricity. The key structural challenge is safely containing this process and managing the high volume of organic feedstock that's constantly moving along that rail corridor.
And the success metric couldn't be more straightforward?
Nope, it's measurable kilowatt from waste.
So you end up with this perfect self-sustaining infrastructure loop. The transport brings the food waste then fuels the transport and the facility, and the byproduct, the compost, goes back to the land to grow more food.
That is resilience engineered into a physical space.
Okay, let's move south. Scheme 4 is the SADC Circular Agro Corridor. This is a complex multi-country system linking Zambia, Zimbabwe, and South Africa.
And this is arguably the most politically complex of all the schemes because it demands active trans-border regulatory integration.
So the core challenge isn't just about materials, it's about minimizing waste across borders while also harmonizing the regulations that typically, bog down logistics.
The brief is acknowledging that infrastructure design can't exist in a vacuum. It has to facilitate political and policy change.
And the physical heart of this is the heavy haul logistic yard. And the mandate for the structure is that it must feature reused metal structural spans.
Which is a big deal. That requires high-level engineering certification. You're using salvaged materials for heavy industrial use. It provides cost savings, yes, but it's also a powerful statement about local resource capacity.
But here's the insight that I think we really have to dwell on. The ultimate measure of success for this architectural project is border dwell time reduction.
Right.
Why is that an architectural metric?
It's fascinating, isn't it? Border dwell time is just the amount of time a truck sits idle, waiting for customs and regulatory approval.
A huge inefficiency.
A huge inefficiency. By designing a high-efficiency logistics yard with optimized flow, standardized material handling, maybe even integrated digital compliance centers, the physical design itself is streamlining a bureaucratic process. The architecture is reducing regulatory friction.
So the success of the building is measured by how fast it moves goods, not just how well it contains them?
It makes the architect part policy expert.
That's a powerful idea. Okay, from regulatory harmonization to industrial waste. Let's look at Scheme 5, which focuses on the Copper Belt. That's Angola, DRC, and Zambia.
And the focus is repurposing industrial waste. This region has a long history of high-volume mining, which has left behind massive tailing piles and all sorts of agrarian residue.
So the challenge is turning these polluting industrial byproducts into useful material systems.
Specifically, building materials and fiber panels to feed local housing markets that are suffering from huge deficits. This is true regenerative design. You're taking the scars of past industry and turning them into social assets for the future.
And the architectural output required is highly specific. They have to design the fiberboard panel press and the modular panel structural module.
Which means the designer has to understand material science. How do you bind and treat copper slag or agrarian fiber to meet structural building standards?
And the impact is immediately measurable in human terms.
Exactly. The metric is the number of local housing units supplied from reused material. The public communication angle is, very appropriately, waste to wealth.
It's a direct, measurable link between industrial legacy, circular design, and community housing.
Now let's round out the continental schemes by looking north to Scheme 7. This is Tangier Med, Morocco, a massive global port.
A huge nexus. It links Africa, Europe, and the Americas. And the brief here mandates the creation of a circular port city.
So this project demands that the circular economy isn't just isolated inside processing plants somewhere. It has to be integrated directly into all the surrounding infrastructure. The port operations, worker mobility, even the housing zones.
And this is where we see that idea of material sovereignty impacting social infrastructure directly. The specific reuse detail required is the design of a modular recycled plastic housing panel for workforce housing units.
Right. Tangier Med handles immense volumes of globally traded plastic. A lot of that becomes waste locally.
So instead of landfilling it,
you capture it. You reprocess it into high-quality, durable housing modules for the thousands of people who actually work at the port. You're tackling logistics, waste management, and social housing all at the same time.
The circular economy model is serving the specific needs of the port community.
And the metrics reflect that. They measure the number of worker housing units built from recycled materials and also the logistics modal shift to ensure that the movement of materials within the port complex is also shifting towards circular models.
So after establishing this internal resilience across all these African corridors, the brief takes this fascinating conceptual leap.
It does. It starts focusing on what it calls the diaspora gateways.
And this is about designing the physical infrastructure you'd need to facilitate economic and cultural trade loops, basically expanding the concept of the nation to be a global one.
And Scheme 8 targets the USA, Savannah, Georgia. Now, Savannah is a huge U.S. East Coast port, a critical logistics hub.
This project is called the Diaspora Circular Trade and Materials Hub.
And the core challenge is very strategic. It's about building a physical hub at a major U.S. port to facilitate the two-way trade of circular materials and food products that are specifically tailored for diaspora markets in the U.S.
So this requires managing incredibly complex international supply chain compliance?
It does. And the architecture has to reflect that duality. The required feature is a cross-dock facility that features a modular reused material canopy.
So even in a high-compliance U.S. port environment, the mandate is still to demonstrate material sovereignty.
Exactly. You have to use salvaged or recycled inputs for the main structure, even there. And the implementation focus is less about local recycling and more about global trade velocity. They have to focus on onboarding diaspora-owned SMEs and tracking the tons of circular materials traded through the facility.
So the hub acts as a kind of physical filter, prioritizing goods and materials that reinforce that core circular economy mandate.
Precisely. And finally, we have Scheme 10, which targets the Caribbean diaspora, Bridgetown, Barbados.
And this location introduces a whole new level of complexity. You've got island resilience, extreme climate risk, and this dual-purpose traffic of cruise ships and cargo ships.
And the brief calls for a circular food materials campus that manages all of that. It has to manage the cruise and cargo flows, process the organic waste from both, manufacture materials locally, and, very importantly, integrate shore power for visiting ships to reduce emissions.
It's an integrated resilience machine.
It really is. And this scheme contains what I think is the most technical and ideological structural demand in the entire brief.
Which is?
The required structural detail is the STS crane beam fabricated from recycled steel.
Okay, an STS crane? That's a ship-to-shore crane. That beam is under extreme dynamic stress.
It's a life safety critical, heavy industrial asset. Specifying recycled steel for that application is not a compromise. It is an absolute statement of confidence in the quality and the engineering capacity of your local circular material supply chain.
It would require just rigorous testing protocols, precise alloy management.
Unbelievable levels of quality control. But if you can trust recycled steel to hoist containers over people's heads, you have achieved true material sovereignty.
It's a declaration. It says our recycled materials are not inferior. They're good enough for our most critical, heavy industrial infrastructure.
And the metrics for this project reflect that resilience imperative. Efficiency is measured by crane kilowatt box, sure, but the ultimate success measure is no cargo days avoided.
So the success of the entire circular campus is tied to its ability to prevent operational downtime, whether it's from a power failure, a climate event, or a supply chain bottleneck.
It has to deliver resilience. That's the bottom line.
We've spent a lot of time detailing these 10 massive interconnected projects. Now we really have to analyze the how and the when, because the source material is a design command brief, and that implies a pace that is, frankly, almost unbelievable.
This is the part of the brief that really demands skepticism. I mean, how does one person or one team design a trans-border logistics corridor or a circular port city, complete with structural details and quantified performance metrics?
And just 180 minutes.
Exactly.
That's the astonishing constraint outlined in the session structure. It's broken into 2 blocks. Block 1 is 90 minutes for the concept, the system diagram, and the environmental performance goals.
And block 2 is another 90 minutes for the actual drawing, the section, the structural detail, and all the performance annotations.
Designing a component as complex as a recycled STS crane beam detail or that anaerobic digester cell in 90 minutes it's extraordinary.
It fundamentally changes what architectural practice even is. This level of speed is only possible if the designers are pulling from a massive library of pre-engineered, standardized, and fully costed modular systems.
So they're not inventing from scratch.
They are not inventing, they are synthesizing. They're assembling certified modules in response to a specific geopolitical and material problem.
So the intellectual challenge shifts. It's not about aesthetic invention anymore. It's about high-speed logistical and regulatory synthesis.
Nice. They must know exactly which structural solutions deliver the fastest border dwell time reduction, or which ones give you the highest waste diversion rate for a given material stream. They have to have that knowledge at their fingertips.
And the required output reflects that need for immediate, actionable clarity. The brief demands 2 specific A2 boards.
The first one is the vision board. The system diagram, the massing it, shows the project's strategic place in the regional flow of materials and value.
But the second one is immediately pragmatic. Plan, section, detail, and those all-important performance annotations. The gap between the big vision and the structural detail has to be bridged in just minutes.
But there's another required output, which I think is just as important.
The public communication graphic.
The public communication graphic. For every single scheme, they have to produce a poster, an article, a video, or a presentation.
This confirms that the narrative is as important as the structure. These are projects of national ambition.
Of course. If the public doesn't understand that this new facility is guaranteeing their food sovereignty and creating local jobs, the project just risks becoming some esoteric engineering marvel.
Instead of a successful nation-building asset.
The designer has to be able to articulate the political and the social value proposition instantly and clearly.
So let's look at the past experiences that inform this intense pressure cooker process. They're in the precedent study section. These are the reality checks.
Right, the brief cites 2 success models. First, it points to Africa's domestic data center growth. That's a clear model of achieving digital sovereignty quickly by bypassing external reliance.
It proves that rapid, nationally controlled infrastructure deployment is actually feasible.
The second success they cite is integrated water and sanitation projects, which show that complex, necessary infrastructure can be models of integrated design.
Yep, there's a but.
There's a big but. The brief uses these successes to frame a critical cautionary note. They emphasize the importance of embedding that environmental performance and local value creation, specifically to avoid failure.
And they cite the fact that water and sanitation access still remains critically poor across parts of the continent.
That is such a profound point. The lesson is you can build the physical asset, you can build the water treatment plant, but if the underlying systems for maintenance, for cost recovery, for community integration,
all those environmental and social metrics we talked about,
if those are not fully addressed from day one, the infrastructure fails. It fails to deliver its core societal mission.
The physical building becomes a monument to good intentions, not a functioning system of resilience.
Exactly. And this is why those metrics are not optional. If the designer doesn't specify how that community packaging hub in Scheme 2 is going to increase the smallholder count, the project will very likely just replicate the past failures of centralized, non-inclusive infrastructure.
Which brings us right back to the working method they describe, the spectrum of scale that these designers have to master simultaneously.
They have to move fluently across 5 distinct scales, all within that 180-minute window.
From the object,
The recycled panel, the crane beam component,
to the building,
the food processing hub,
then the district,
integrating the housing and the recovery center,
the city region,
the Lagos Periphery Campus,
and finally all the way up to the trans-border systems.
the SADC corridor logistics.
To think across all those scales at once, you would need an encyclopedic knowledge of material science, logistics, regional regulatory flows.
You are designing a geopolitical system. You are not just designing a structure. It's the ultimate synthesis challenge. The architect has to ensure that the choice of material at the object scale, that recycled plastic panel, aligns perfectly with the strategic goal at the transborder scale, which is reducing regulatory friction and maximizing local sovereignty.
Every choice is a calculated move towards autonomy.
It has to be.
So this document, the KAMBUF National Building Design Command Brief, it's radical. It shows us that high-level architectural design is now merging completely with advanced logistics, environmental science, and, explicit geopolitical goals. The mandate is clear. Design is now a strategic tool for achieving sovereignty.
The ideology that underpins every single structural specification is right there in that directive. Food is power, materials are sovereignty. We've seen how they execute on that, from a smallholder packaging hub in Kenya all the way to heavy industrial infrastructure demands in the Copper Belt in Barbados. It's concise, it's actionable, and it demands an unprecedented integration of disciplines.
It sets an incredibly high bar for the design profession. It demands that designers not only conceive of a building, but that they calculate its environmental and its economic impact, the cocoa reduction, the border dwell time efficiency, all before the design ever leaves the table. The objective is to build the loop, own the resource, and expand the nation.
And the entire system, as we've said, relies on speed, on standardization, and on a vast body of pre-prepared knowledge about modular systems. We've just reviewed the immense complexity of these 10 interconnected schemes.
Which brings us back to the provocative thought that we have to leave you with. We know these architects must deliver a full circular economy concept, complete with structural detailing and quantified performance goals for transborder systems in just 180 minutes. If that is the future of critical infrastructure development, what does that imply about the nature of architectural knowledge itself? Does this demand that design become fully codified, standardized, and modular, meaning that the architect's primary job is no longer drawing unique buildings, but performing high-speed, strategic, geopolitical calculations based on a menu of pre-certified modular components? What level of standardization must we accept to deliver sovereignty at this pace?